Suppose we have a system of linear equations where we represent the coefficients of our variables in the matrix A, and we place our variables in a column vector. And also our constants on the right hand side in a column vector. So therefore this system can be written using our matrix of coefficients by x equals b. Now if the inverse of A exists, which we've shown previously using Gauss-Jordan elimination, and recall A was a square matrix with the same number of rows as the number of columns, then the system of equations Ax equals b has exactly one solution. So if we multiply both sides by the inverse of A, which we've shown to exist, then this equation becomes x is equal to the inverse of A by b. So for each vector b of these constants on the right hand side, there's a unique solution. And I encourage you, as an exercise, to use matrix multiplication to evaluate the product on the right hand side to obtain x, which contains our unknown variables.